This video is going to look at an introduction to acceleration problems. These questions involve a lot of word problems, so if you haven't seen a video and worked through the steps on how to solve word problems, please click the link in the top right. Example 1 says a cyclist starts from rest and accelerates for 4.3 seconds to a final speed of 10.5 meters per second. What is the cyclist's acceleration? We always start by writing what we know in a list as well as what we don't know. Okay, so from this example, we can see that the cyclist starts from rest and accelerates for 4.3 seconds. That means that my change in time is going to equal 4.3 seconds. I'm then going to write the initial velocity, and as the cyclist starts from rest, it means they're not moving. So that's my initial velocity, or VI, equals 0 meters per second. And we know the cyclist has a final speed, or a VF, of 10.5 meters per second. The question asks us, what is the cyclist's acceleration? So I'm going to identify that by A equals question mark. To come up with my equation, I'm going to use the acceleration triangle and write the equation as I see it. So acceleration equals the change in velocity divided by the change in time. Now I can take those numbers in the equation and substitute them. 10.5 meters per second divided by 4.3 seconds. I can do that calculation to get 2.44 meters per second squared. I then have to go back into my word problem and say how many significant figures are there. I know that the time of 4.3 seconds has 2 significant figures, as well as the final speed of 10.5 meters per second has 3 significant figures. Least significant figures means I have to write my answer in 2 significant figures. I can rewrite that as A equals 2.4 meters per second squared. Make sure you have the correct units and your answer is in the correct amount of sig figs. The second example reads, a runner accelerates at an average 2.5 meters per second for 3.5 seconds. What is her change in speed at the end of the 3.5 seconds? As always, we have to identify what we know in a list as well as what we don't know. In this question, we know that the average acceleration equals 2.5 meters per second squared. We also know that the change in time is 3.5 seconds. And the delta V, or the change in speed, is what? That's what we're looking for, so we write that with a question mark. We're going to use the acceleration triangle to determine our formula. We can rewrite that as delta V equals acceleration, or A, multiplied by the change in time. We can substitute our numbers to get acceleration as 2.5 meters per second squared. I use the factor label method with this so that my units, it's easy to see my units cancel. We're multiplying it by 3.5 seconds. Seconds on top will cancel with one of the seconds that are on the bottom. We can rewrite our formula as delta V equals 8.75 meters per second. The next thing to do is check to see you have the correct sig figs. We do that by checking our initial question. 2.5 meters per second squared has 2 significant figures, and 3.5 seconds also has 2 significant figures. That means our final answer must be written with 2 sig figs. I can rewrite that as delta V equals 8.8 meters per second. Make sure our units in meters per second make sense for delta V and put a box around it. The third example says a longboarder is rolling down a hill and increases his speed from rest to 3.0 meters per second. If the average acceleration was 0.70 meters per second squared, how long was he on the hill? To get started, identify what you know and what you don't know. In this example, we know that the initial velocity is 0 meters per second as he is at rest. We're not moving at all. That makes it easy. It's always going to be 0 and whatever units you're working with. The final velocity, VF, equals 3.0 meters per second. We know the acceleration equals 0.70 meters per second squared. And the change in time is what we're looking for, so delta t equals question mark. Use your acceleration triangle to come up with your formula for the change in time. We can write that as delta t equals delta v, or the change in velocity, divided by acceleration. Now we have to substitute our variables. Change in velocity is 3.0 meters per second. We're going to divide by acceleration using the factor label method. So it's 0.70 meters per second squared. We're going to check to make sure that our units in meters on top will cancel with the units in meters on bottom, and seconds on top will cancel as we divide by seconds on the bottom. Doing that calculation, we're going to get our answer as 4.286 seconds. As always, we need to check back in our question to see how many sig figs our answers have. We start with 3.0 meters per second has 2 significant figures, and 0.70 meters per second squared has 2 significant figures as well. Final answer must have 2 sig figs. Delta t is going to equal 4.3 seconds.